Welcome to part 2 of this series on building the PETS algorithm from scratch with the Lunar Lander environment. All right, so we're going to kick off with just some project setup stuff. I'm going to be using NeoVim on Linux. You don't need to use the same environment and setup I am, as long as you have an editor that you like and you have some way to set up a Python environment or a Python virtual environment. And I would recommend some kind of virtual environment. In my scenario, I'm going to be using Anaconda to create that virtual environment. So let's go ahead and do that. So in this case, that command is conda create-n, and we're going to call this lessons_pets Lunar Lander. And I'm going to set this up with Python 3.12. And that'll take just a moment. And I'm just going to say yes here. And again, any tool that lets you set up a virtual environment in Python is going to be fine. If you have no idea what I'm talking about when I say virtual environment, it might be a good time to go work through a Python course. That's really the only prerequisite to these videos, is a good solid understanding of Python. If you have some reinforcement learning experience, that will also help to put this in context, but you don't have to have deep reinforcement learning experience for the series. So let me blow this up a little bit so you can see my screen a little bit better. So I'm going to go ahead and say conda activate lessons pets Lunar Lander. And let's hop back over here, and we're going to create a requirements.txt that will have the various Python requirements that we need to build this project. So I'm going to say TensorBoard is always a requirement. And then we need a extra index URL. In this case, I want to be able to pull the CUDA version of PyTorch. So I'm just going to paste that. You should grab the one that is appropriate for your version of CUDA. If that's not it, grab one that is. And then we're going to grab Torch, Torch Vision, and Torch Audio, which is just kind of the standard set. So let's come over here, and I've already activated the environment, so I'm just going to go ahead and run pip install -r requirements.txt. And that is going through and grabbing all of the right CUDA enabled libraries for me. And again, CUDA enabled is something that is able to use your GPU, which is going to be very, very helpful for this project. While that's building, let's go ahead and we're going to do a little bit of framework. So I like to make things as easily testable as possible, and to start in as small a chunk as possible. So I want to build things that we can quickly run and try and iterate on. So let's go ahead, and we're going to need two files to start with. We're going to need an agent.py and a train.py to kick that off. And what we're going to do with these two files at first is we're going to go ahead and establish the environment. So in this case, we're going to be using the Lunar Lander environment, and we're just going to get some fake movement flowing through it so we can make sure that everything is all nicely wired up. And I am going to go ahead. I copied my build.sh. You do not need this unless you are using an editor that doesn't have a default Python kickoff. So we're going to say lessons pets Lunar Lander. All right, so at this point, let's go ahead and just make sure that our Python environment is working with the traditional print hello world. I said I like to test things quickly. All right, so we now have a functional just a basic Python environment up and running that we can use to start building our project. So let's go ahead and start our agent. So we're going to need a few things. We're going to need to import gymnasium as gym. And actually, let's go ahead and add that to our requirements.txt as well. I'm pretty sure I have gymnasium installed globally, which is why it works for me. But we shouldn't rely on any global packages. All right. So in agent, we're going to import gymnasium as gym. We're going to go ahead and import torch because we'll be using that later. And then we are going to import date time. We'll be using that later as well. And then we'll also do from torch.utils.tensorboard import summary writer. Nope, not summary. All right, and it doesn't like that. Let's see. Did we also? We did have tensorboard. We'll come back to that. Just going to comment that out, and we'll figure out why it didn't like it later. One of the things that I like to do is to structure both the environment setup and the test and train methods inside of an agent class. So we're going to say class agent, and we'll do def init, and we're going to leave the pass in there for the moment. We're also going to need a def plan action, and we'll do a pass as well. We'll just go ahead and stub this class out. So we'll need a def test, plan action gets self as well, and we will need train. And a pass. All right. So we now have just our basic stub. So let's go ahead up here at the top, and we are going to accept an environment of type gym.env. We won't always do types, but in this case, it is going to help us because the editor will understand what we're trying to do. And then we're going to accept a model count parameter that we'll use later. Remember, this pets is an ensemble of models. It is multiple models. So in this case, we're going to be running it with 5. So we're going to go ahead and do we'll set a max memory size. Which can be a lot smaller than some other algorithms. We're going to do 10,000. We will do a self.batch size of 512. And then self.env will be equal to env. Simple enough. We don't really need anything else yet up here in init. So let's go down to train. And again, we're just looking to get some basic scaffolding set up, something that lets us run the environment and see it operate. So we're going to declare a total steps variable of 0. We are going to set a best score, and the score can be very negative. So we're going to set a default best score of -1000. So we always have an opportunity to override it. And then here we're going to say for the train method needs an episodes parameter. And we're going to say for episode in range episodes. We will do done as false. Episode reward is equal to 0. And then we're going to go ahead and call our env reset. So obs info is equal to self.env.reset. And then we're just going to play an episode. So we'll say while not done. And then we'll say, we'll use this later. So if episode is less than 10, so for the first 10 episodes, which will be, again, our test anyway, we're going to say action equals self.env.actionspace.sample. And then we'll say else pass. Or actually, let's go ahead just to make sure everything works. We're going to say that both actions have, the if and the else here are both the same thing. And then we're just going to do a to-do to add pull from plan action. Okay. And you can see our plan action method is one of the ones that we defined up here. So we're going to be pulling from plan action later. That'll be once the models are successfully trained. Right now we're still in stubbing out phase. So down here, we're going to say next obs reward done truncated info equals self.env.step and action. We are going to add a to-do to come back and store memory transitions. Again, right now we don't even have a memory. We've got nothing we can play with. So nothing here to do. We're going to say obs is equal to next obs, because we always need to reset that after we've done the storage. And then we will say episode reward is equal to episode reward plus reward. All right. And then if done or truncated, break. Okay. And I don't think we're collecting episode reward yet. We do have episode reward up here. We do have, let's see, Y for literal and supports float. I think that's going to be okay. I think that's just my my editor complaining at me for now. So let's go ahead and head over to our train.py, which is going to be our intro script here. And we're going to say from agent import agent. And then we'll just say agent equals agent. Let's go back and see what params we wanted it to accept. So we need to accept a gym environment, and we can use the default model count. That is just fine. All right, so back over here in train.py, we are going to go ahead and declare our environment. One of the things I always like to do is to time things. So start time equals time.perf counter, which will require us to import time. Okay. And then down here, we will just go ahead and wrap that with elapsed time is equal to end time minus start time, and print elapsed time was okay. That's fine. And then we also need, we're just going to copy that and paste it and then do end time. Okay. So our agent still needs some parameters. Let's go ahead and test just this block. All right, cool. Our elapsed time is working. It's doing what we want it to do. Again, make time to quickly run your code as you're going. You're going to find bugs a lot faster. this is a great time to go and do a quick exercise, pause the video, and see if you can find the right gym.make command to pull the Lunar Lander. So it's going to look something like env equals gym.make and then something here. And it will be in the gymnasium documentation, which I will link in the video description. So go look at that, figure out how to set up the Lunar Lander, pause the video, come back. All right, hopefully you took a shot at that and you got the Lunar Lander environment up and running. If you didn't, here's how we're going to do that. We're going to say Lunar Lander -v3. We will be saying continuous is equal to true. We're going to set gravity to -10.0. We're going to say enable wind is equal to false because we don't want wind. We'll set wind power, which may not be strictly necessary since we set it to false, but that is how my original project was set up, so we're going to keep it. Turbulence power is going to be equal to 1.5. And then in this case, we're going to set render mode to human. Later on, we are going to set that to RGB array. But for now, we actually do want to display it just to make sure that, that we are, actually running the environment. All right, and then we're getting an error on gym because we need to come up here and say from gymnasium import gym. Not from gymnasium import gym. Import gymnasium as gym. That is the correct import statement. All right, let's go ahead and run this. And we do not have box 2D. And I'm remembering now, as I'm hitting this error, exactly why gymnasium was not in my requirements.txt, because it had to be specifically installed with the box 2D package. So let's see. I'm going to pause and go find that command and come back to the video. All right, I'm back with a successfully resolved error. I had to make two changes. The first was over here in requirements.txt. I had to add swig and the box 2D requirement under gymnasium. And then the other was I actually needed to run a conda install -c conda forge libstdcxx. Now this is probably very specific to people running conda on Linux. The error I was getting for this one was a glib cxx3432 not found. So you may not see that error and you may not need to do this, especially not if you're not using conda, but you will need to go and add swig and the box 2D gymnasium. So that's working. We're now running, but it's not doing much of anything. Well, it wouldn't be if I didn't have some cached code there from making sure it worked before we hop back in. So if I save this, it is now not doing anything. So the change we need to make to actually get the environment to run our code is we need to just run agent.train. And we're going to say episodes is equal, let's go ahead and make a variable for this. So episodes, we're going to do 10. And then down here, we will say episodes equals episodes. And what this should do is this should run the code that we just put together to run the environment 10 times. And of course, right now it's just completely random, executing the environment with random steps, and the Lunar Lander is predictably dropping out of the sky. So this feels like a really good place to end the video and move on to the next one. I am going to upload all of the code for this with tags associated with the parts. So in the video description, you're going to find a GitHub link with a part 2 tag that will be a link to the code as it currently sits in my IDE. So if you've coded it all out up to this point and it's not doing what it is on my screen, you will find that part 2 link and you'll be able to reference the code and go and fix it. My recommendation from a learning perspective is to do everything you can to avoid looking at that code base. If you're running into a bug throughout this series, take the time to dig in, try to fix the bug, try to solve the problem, because you're going to get a lot more out of it if you do that. But if you need the code, it is out there. If you need help outside of the code, through the whole series, post it in the video description, or there's going to be a Discord link down in, and I should have said post in the comments. I've said video description a lot. If you need help, post in the video comments, or there will be a Discord link down in the description. In our next video, we are going to start building out the replay buffer to allow batch training of our future models. And that will be where we will pick up in part 3 of this series. So with that, I will see you next time.